Well, thank you for joining us here today. Really appreciate your time for our fireside chat. Missing the fireplace, but that's good. All right. Get a little flamethrower going, right?
Yeah.
All right. I find it fascinating that the definition of SDN that is currently emerging focuses somewhat less on the decoupling of the data and the control plane and more on providing programmatic interfaces into networking equipment. And as a result of this effort, enterprises and carriers will gain what I perceive unprecedented network programmability, automation, and control, enabling highly scalable, flexible solutions that readily adapt to changing business needs. And that's the real crux of this question, that we readily adapt to changing business needs. So here's the question. How will Level 3 implement this functionality that makes the network application aware, and how will Juniper provide it?
Okay. Sure. Yeah, I'd say that at this point we don't really have much to implement because there's, while there's a lot of science experiments going on in the marketplace right now with the different vendors, there's not something meaningful enough for Level 3 to actually execute on in our network. Now, the way that we envision this happening is that is right now we see most of the progress seeming to be made across layers if you break it down into the different stacks of the network. And I would envision that our initial implementations of SDN are going to probably be small experimental deployments along layer 1, the optical layer, layer 2, and layer 3. But ultimately, we really do believe in the vision that we've got to be able to drill down through the layers and get every stack communicating with each other. And the whole issue around application, the network being application aware is a really good point because there's just so much room for efficiency in the networks today if we could achieve that goal. I mean, every service, every application being provisioned with its own bandwidth and with its with its own class of service on the network, and without the communication going down through the network to be able to take advantage of available capacity that's set aside for one application when there is some kind of a network fault or problem on the network, or being able to make priority decisions between those is really, it just creates tremendous room for improvement and efficiency in the overall function of the network through the layers of the stacks. So we really believe in that vision of trying to achieve that and use SDN to help us get there. But as far as implementation right now, we're still feel like we're largely in kind of the science experiment stage of it.
Mm-hmm. Yeah. I would agree with that. I think SDN is not an answer right now. It's a question, and we have exploration to do.
Yeah.
And it's interaction between vendors and providers who use it that'll get us to the right place in this whole thing. One of the things we talk about applications controlling the network. If you pop up a level, what you have is people saying, I want more control over my network. I want more efficiencies, as Paul just said. I want to be able to use the resources I have better. And to do that, I need agility. One of the analogies I like to use is compute virtualization. Compute virtualization is great technology. But the big question is, so what? And what compute virtualization gives you is a much more efficient use of a server. If I put one dedicated application on a server, I'm not using my server well. If I put 5 VMs and I can put more and I can put less, I am using my server more efficiently. And I need the orchestration that says, I'm going to put 5 VMs there. And if one of them is suffering because the others are taking too much CPU or memory, I'll move it away. So that ability to be agile is what makes compute virtualization such a powerful thing today. Not emulating one CPU over another. That's technology. But the actual business case. So I think that's what we want to explore. So to your point about what kind of interfaces, what kind of APIs do you show? Well, Juniper always wants to do things in an open standards way. And one of the things we're looking at is instead of actually having an API, a programmatic API, we're looking at data models. tell me what are the resources you want to optimize. Tell me what are the parameters you want to play with. And then, whether it's bandwidth at layer 1, whether it's resiliency, because part of layer 1 is, can I get the right resiliency? Is it something going on at layer 3? Is it something going on at layer 4 to 7? What are the parameters you want to play with? And can I give it to you in a data model that captures the semantics of this, not just here's an API in C or in Python or whatever your favorite language is. And so we're looking at creating standard data models that captures the kind of control you want on your network. And then, and I think this is something we need to play with.
Yeah, to add to that, I think that your point about an open API is really critical. One of the things that as running product management, that is kind of a golden rule that maybe other product managers in the audience will share is that you never roll out a product that is completely dependent upon one vendor's equipment, where you become, it may be a great little flash thing that you can do and it's cool whiz-bang stuff for now, but then if nobody else is, if you don't have an ability to replicate that in other parts of the network, go across vendor platforms, then you really put yourself in a bad position for the future because you don't know how dedicated that vendor is to what you're doing and what you want them to do. So that's one of the biggest problems that we see with it, and I really think that a lot of the kind of experimental implementations we've seen so far has been a lot with vendors that say, okay, well, I teamed with this company, I'm a layer 1 company, I teamed with this layer 2 company or this layer 3 company to do this, and then we brought in this software company to do this, and look at this great thing that we did to prove in. It's great to prove in as to show what is the art of the possible, but it's not something that a big carrier can implement and productize and roll out as a service to companies because of reasons like that.
Yeah, it reminds me of a story I heard recently from a large bank in New Jersey. They told me they had 6 more inches of rain during Hurricane Sandy. Their largest data center would have been wiped out. And what they would have liked to have done is 24 hours prior to Sandy arriving, they would have liked to have provisioned additional bandwidth to a backup data center and start moving all their virtual machines from that data center out of harm's way. Unfortunately for them to get the wavelengths, set up these switches, the LAN switches, and to go to the applications group, fire up the virtual machines, move the data stores, in their view takes them anywhere from 1 to 3 months. So, what they were looking for is a solution that would allow them to do this in literally 15 minutes. And this has been demonstrated. This has been demonstrated layers 1 through 7, completely application aware, where an SDN controller sees a condition where you're going into server overload, it automatically provisions the wavelengths, automatically provisions the switches, and then kicks off through VMware and vSphere and vMotion and vStorage the migration of these virtual machines. So we can show this working. We've actually demonstrated it. But the question is, how do we implement it? How do we roll it out? How do we make sure that it's open? Yeah. And I think that's the real key, is we talk about all these different layers, okay? And I'm at layer 1, you're kind of at layer 2, and we need people that are going to take this right up through layer 7. How do we do that? Do we need a systems integrator to partner with us? How do we take that forward?
Well, I mean, if we go all the way up into layer 7, then yes, we're at level 3 doesn't have the kind of software expertise to really work at it all the way up to those layers, and that would be a pretty big extension for us to try to build that capability and come up with that. So I think systems integrators this may be a possible role for them to play in coming in and helping out with us, helping out with that. There can be, I mean, that's the great thing about as this technology evolves is that new roles are going to emerge in the marketplace for different people to come up with different solutions. We could, level 3 could work out with our vendors the layers 1 through 3. And then other companies could come in and bring in, and if we can do that in an open standards way, then there can be companies that emerge that work at the upper layers to offer different, types of ways for us to package our service with them to create a totally new service. Just the way that apps have evolved off of these different mobile platforms and everybody has a different spot in that ecosystem piece. So there's a lot of ways that it could be, that it could emerge.
It seems like virtual machine mobility, workload balancing, these are new capabilities that didn't exist 5, 6, 7 years ago within data centers. Within data centers has been such dramatic change in the last 5 years. And that's causing dramatic change. You know, we've got server virtualization, storage virtualization. What we're missing is the network virtualization.
Yes.
And so that's, what's your view of that?
Well, I agree completely, and that's why I gave the analogy starting from compute virtualization, that the orchestration is the big difference there. And now that needs to leak into the network, not only the network in the data center, but the network between data centers, between the users and the data center. So the ability to do all this network virtualization and network orchestration. But I think one of the things, we now are beginning to talk about high IQ networks. And I think, to your point, I think, you know, where do system integrators come in? Juniper does write software, but we don't write enough software, and we can't cover all of this. One of the things that we want to do is make these APIs, these data models available. And I think Paul talked about the multi-layers, right? So you have layer 1, layer 2, layer 3, and then you have all the layers above. Make them available and give people the ability to then say, I can take these different things that are happening at the different layers and use that to orchestrate my network. One of the things that people talk about in this whole process is they talk about automation and orchestration. They don't talk enough about analytics. And I think now they're beginning to talk about analytics. For me, when you close the loop, I'm going to, you know, place a service here, you know, whether it's place a VM here or put a VPN here or put a Lambda here. I'm going to do that. I'm going to do that based on analytics. I understand what the application wants. I understand what the consumer wants. I understand what the network needs. Place something here, and then constantly monitor it and say, hey, this worked yesterday, but there's a shelf life for optimization. That shelf life is expired. I need to re-optimize. I need to move this from here to here. So you're talking about, you know, vMotion. There's storage motion. Yeah. There's also network functionality motion. So I have a firewall here, but I need to move it here because that's where the action is. I have a VPN instance here. I need to move it there. There's a Lambda that's going this way, but I need to move it in a different direction. And so I need to close the loop. It's not enough to say, I did a good job of optimizing now. I need to do it again, and I need to do it constantly. And that whole loop, I think, Juniper is not going to do that, right? We can say, here's the analytics, here's the ability to orchestrate the network, especially layer 2 and above. Someone else will do layer 1. You guys are there. But someone needs to put the whole thing together. And someone needs to say, this is how I close the loop. And someone needs to talk to level 3 and other providers and say, what do you guys want? How do you see this loop? What's your business rule for placing a circuit here or a VPN there or a firewall somewhere else? And incorporate all that into saying, I have a network that's responsive. So I think the key things that you want the network to become is agile and responsive. So to your point about, you know, Sandy and 6 inches of rain, right? What if I didn't actually have to push a button? I didn't have to send someone there. I can actually sense that, hey, my circuits are not doing well. Maybe there's, you know, the fiber is getting wet. I don't know what happens when fiber gets wet. Or maybe there's a bend in the fiber and my bit error rate is going up. Proactively move stuff around, right? So make the network intelligent. And so that's why we talk about high IQ networks.
And I think that your virtualization of the server analogy is interesting because today we can fire up virtual machines on demand. I don't have to go into the server. I don't have to open it up. I don't have to play with any cables. You know, I basically set it up once and I leave. And everything else is configured in software. Why can't we take that model and put it right onto the network, where I configure the network once, and everything else is logically done in software so I don't have to touch it again? Yeah. And does that model work? Do you think economically that model works to build it ahead of time and provide that type of service offering versus building it piecemeal when a customer wants it? Because it's that whole agility issue that's getting in the way, right? This whole new paradigm where we need to have agility and speed and access versus waiting 3 weeks for a provider to provide me with the circuits, right? And I think that's the analogy. I was curious if you see that same thing being required with the network, and is it economically feasible to do that? I think that's the big question.
I'll pick up on one thing. You've mentioned a couple of times, you know, it takes me 6 months to do this, and or 3 months, and I want to do it in 15 minutes. There's a different aspect to this, which is, I think, really important too. And I don't know if level 3 sees this, but I know that a number of people see this, which is the expression fail fast, right? What does fail fast mean? It means I can experiment with things. I can see if they work. If they work, great. I'll put more into it. I'll productize it and whatever. If it doesn't, I'll move on to the next one. And I can't do that if it takes too long and it's too expensive. And so this idea of being able to put something up, let's go back to server virtualization. If I think of a new app and I have to buy 50 servers and I have to tell my boss why it's 50 and not 10 and not 100, it just takes too long. And if I get it wrong, I get fired. But if I bring up 50 VMs and play with that and say, yeah, that was too many, I can pull back to 20, right? That works. And so our ability to do that in the network, to be able to put up a service, to put up some instances and dynamically move around and say, I need more, I need less, and do that at low cost and high speed so I can actually play with things. I don't have to, I mean, it's not just, it takes me 3 months to do it. The analysis might take me 6 months. Is it worthwhile from a business point of view? Is it worthwhile from a bunch of, the physics, does the physics work out? I can't do that. I need to be able to experiment with things.
That's very fascinating because people have separate systems in their data centers just for test.
Yes.
But with virtual machine, they just fire it up, test it, bring it down. So there's no longer this dedicated model of test systems anymore. Right. It's dynamic. Yeah. And we want to bring that right into the network. And I think our customers, our mutual customers, would really like to have that. Yeah. But the question is, how do we deliver it to them? And like we said, I'm an enabler at layer 1, layer 2, 3, 4 through 7. We got to get another player here and another chair, and we all get together. And the first people to do that, yeah, the first ones to do this are going to make a real difference. They're going to really, you're going to get a lot of attention.
But the economics have to work from the carrier, the service provider perspective. Ultimately, we'll do whatever we think is going to make money. And so there's a few things that figure into that. There's the cost of the technology and implementing it and the integration piece of it itself and all that development expense that goes in there. And I think that most carriers like Level 3 do believe in this technology and the future of this technology and see the promise of the cost savings that it can deliver. But those costs figure into our equation of how, what's the timing and how much energy do we put into it. We are past the days of, doing crazy science experiments and spending a bunch of money just for the sake of showing, people, oh, look at what cool thing that we did. So there's that element, but then there's also the element of then how do we transform that into services for customers, and what are customers going to want to buy, how much are they willing to pay for it, and can we afford to do it for the price that they're willing to pay. And some of the things that strike me about this technology that we've been playing around with in terms of analyzing that is how. How are end customers going to use this technology? Let's say that we were able to wave the magic wand and make a service like a burstable service like you were talking about that, in downtown Manhattan that enables all this stuff. What if we were to do that and just say, okay, I've got that at my hands now. How would I sell it? How would I price it? What would they be willing to pay? And there are things that stand out to me that are questions that I don't think that we've been trying to get to, but a lot of people still don't know, and it's still evolving. Things like you don't know how much is a typical large enterprise customer using hybrid cloud services. How often are they going to want to turn up and turn down bandwidth? How much burst excess do they need? How often is it between the same common points? Is it only on the weekends, or is it well distributed out? If we sell this burstable service to 100 different banks, and all of them use it for the same application, and it's always on the weekend, then that economic model isn't going to work for a carrier. Yeah. So those are things, and I talk to customers about this, and I say, well, how would you use it? What would you, and a lot of times more often than not, the answer that I get back is that we just don't know because nobody's ever offered it to us before. Exactly. And so maybe there's a certain element to it that is kind of like, I love, the Steve Jobs analogy of, You know, I don't ask customers where we need to go. I tell them where they need to go, kind of a thing. And maybe there's some element of this in that, but that's part of the issues that, at least in our mind as a carrier, is that we're trying to deal with to get our heads around back to the economics question. What's it going to take?
But you could also use the fail fast model there. If it didn't cost you a lot of money to put up a service,
Sure.
and then have customers play with it and say, hey, I really want, I like this, I want to pay you money for it, versus it was a good idea, but let's move on. If it costs you a lot of money to do that, you can't do it. But if you could fail fast and you could do it quickly, easily, and didn't cost a lot, and you could then trial it, then maybe it's something you could play with. So it's not just a technology.
And ultimately, the thing that keeps me really engaged in this is kind of a fear of, look at what happened in the computing industry when companies, what was the storage vendors' motivation for doing virtualization? There's kind of a parallel to like a carrier who's saying, well, gee, I'm selling all these servers, and if I enable all this virtualization, then people are going to need less servers, so I shouldn't do that. Carrier parallel is, gee, I've got this big network, and I'm selling it under 1-year terms, and it gets locked in, and it's a guaranteed revenue stream. Why would I virtualize it and enable people to just consume it on demand? The people making compute and storage, if they had clung to that idea, then they'd be out of business, right? And the carriers, I think, are, we've got to watch out for that same trap. The thing is, in the end, we want to be where the customers really need us to be, and because they're going to find a path one way or another to that endpoint, and if we don't provide it, then somebody else will.
Well, I think server virtualization is an interesting analogy because it's the only technology in the last 10 years that I've seen that gives you an order of magnitude 5 to 10 times savings. Okay? When I apply that model to storage virtualization, I don't get that. And that's why storage virtualization hasn't really taken off the way server virtualization has taken off. So we apply that same model to the network. Is there 5 to 10 times order of magnitude better by virtualizing the network? Now, the customer's going to love it if you can get them down to those price points. But that's a big question mark.
Yeah.
Do I really get that savings? And maybe it's that decoupling of the control plane, the data plane, and this whole white box initiative, right? Where people are going to go out and put in these boxes and put in intelligent controllers. Maybe that is an order of magnitude better. We have yet to see that. I mean, clearly Amazon has shown that they're very willing to invest in that, and it saved them a lot of money. So I think that we have some fascinating things to work through here, And I also see another example where today you have customers in the New York area, like you said, and they have dedicated wavelength services from you. But what if Level 3 were to come forward and say, on top of that, I'm going to give you an insurance policy that says if you need additional bandwidth on demand, you pay me a certain amount of money, and I'll have this overlay network. And it will be available to 10 customers, not 100. So you can determine your SLAs. You can create priorities of service for 10 customers, large customers, that are looking for that situation where they have a natural disaster and suddenly they need that extra bandwidth. And Level 3 is there to provide it. No other carrier can provide it on demand as an insurance policy. I would think that would be a kind of nice model to have both. They talk today about going to open flow, but also maintaining your existing network. There's got to be a migration path. There has to be a combination of these two solutions together, and they'll compete with one another a little bit. And I think that would be beneficial to customers. I guess the
way that we would approach that, though, today is that, and maybe this is the network guy's mindset, but we would look at those 10 customers and we would say, okay, if we overlay all this bandwidth, then it could sit there and never be used. And then we'd lay that into the extra cost, and it's effectively you're not doing the same thing. Now, I think another twist on that, though, that may have promise as an experiment, as you said, to test the fast fail issue, is if you can set up a service between a small number of locations that are really dense with activity, with a lot of traffic potential ups and downs, and a lot of people moving stuff around, then you could actually get a kind of representative sample of what these profiles look like, how people are going to use it. You kind of need enough. You don't need a base of 10 customers that use it every once in a while. That it's a nice little safety mechanism. What you need is a bunch of customers that you never know when they're going to hit, and they're going to grab it and they're going to let it go, and then the next customer is going to do it. That's where you really get some insight into how the economics of these networks work.
You need a lot of large numbers. You want statistical multiplexing,
right.
but at different. I mean,
but what if you're a cloud provider? I've got 5 cloud providers on the back end, and you're my customer on the front end, and I want to allow you to switch into anyone you want on demand, based on better pricing. I don't want to wait a month to switch from this cloud provider to that. So almost it becomes a service offering the same way that you would offer up anyway.
And then SDN becomes more of a disruption at the business model. I think one of the things that Paul said is, do I take my, here's my 10 gig circuit, I lease it for a year, and I get a steady revenue, and I move to a pay-per-use model, and I might get more, and I might get less. Okay, we can make the technology available that you can do that, but will people pay enough on that pay-per-use model, especially after we've sort of spoiled them and said, here's a 10 gig, it's your 10 gig for a year, don't worry about it.
Well, we did our cloud pilots in 2009 with IBM and Level 3 media customers that didn't want to build out their data centers in New York City. It was way too expensive. Storage was just causing a problem. So we would cloud burst into an IBM cloud facility. And that did not take off because the cost of the circuits were 70% of the cost of the cloud service. What if we go back to that model again? We go to those same customers and say, we want to do this again with you, but now we'll give you the wavelengths on demand for when you need to cloud burst into that facility. And they know when they need to cloud burst into that facility because they're out of room in their data center. And then we take that to the next step and say, it's not just the IBM cloud center, it's this cloud center, that cloud center, and we'll switch into anyone you want. And all of a sudden it becomes a very interesting discussion. And the savings really isn't necessarily in the network, it's in the service, the overall service, end to end.
Yeah.
So, what do we do about this being secure?
Well, I think that, I'm not the layer 3 security expert at level 3, but when we talk about services like this, that is certainly a concern, because anytime that you create an API that allows somebody to interface electronically into the controls of the network, that just raises big concern. And it's not something that you can, even if you just isolate it to, you can alleviate some of that concern by isolating it to a particular layer of the network, or carving off a partition of the network or a separate physical network and say, okay, this is the network we're going to use for that. But it's still, customers have great concerns over that. So we're going to have to come up with the proper controls in terms of not just from from the idea of hacking into the API or managing the interfaces to access it, but work has to be done in terms of the controls around just how customers, how you manage conflicts of demand between different customers, and keep one customer from overriding another customer's bandwidth as they use it in the network.
And that's not only the network, but the cloud facility itself, right?
The whole thing. So I think the big thing here, there's security, there's policy, right? And I love to work with analogies. So the analogy I'm going to use is ATM, but automated teller machines, not asynchronous transfer mode. If you have an ATM, you can go in and deposit money, withdraw money, look at your balances, move things between accounts, but you can't create a new account, right? So around ATM, self-service is huge, right? It's all about self-service, but it doesn't mean you can create accounts. So there's an implicit policy there that says, this is what you can do and this is what you can't do. And to Paul's point, if you start opening up APIs to your customers, you have to put policy around this. This is what you can do and this is what you can't do. And to your point about, if you grab this bandwidth, somebody else will get hurt. You have to have policies. So there's two different things. There's security and there's policies. And I think the policy question is much harder. The security question is much deeper. So, but opening up the network and giving that kind of access, I'm sure the banks had the same sort of heartburn. What do you mean we're going to let people just go and query their accounts and transfer money and stuff? They got to walk up to a human being to do this. So, no, not anymore. So in doing that in the network, I think we have similar sort of heartburn, and we have to get over that in the right way.
When you use SDN and everything, all your flows are monitored from one location. So you can take a look at the topology from the SDN controller, and you can measure those flows. Doesn't that give you the tools to create that policy and to also limit the flows that certain customers can request based on that policy?
So the centralization of SDN is, for me, I get a negative reaction when you talk about centralization. But what's important to me about centralization is we look at the network box by box, and SDN says step away, look at the network as a whole. So to your question, having a central place where all this happens gives me the tools not to create the policy, but to base the policy on. Right. I still have to create what the policy is. Do I allow Paul to have 50 flows or 500 flows, or 50 lambdas or 500 lambdas? Do I, if someone else wants a lambda, which Paul is using today, do I preempt his lambda? So I think by centralizing things, I make it possible to create these policies, but we still have to figure out what the policies are.
Mm-hmm. And the bigger question is who's going to do that work?
The system integrator you talked about.
Exactly. When we look at security, we can do it at different levels, right? You can do it in the server, choose up CPU cycles. You can do it in all your routers. We know what that does. We can set up separate boxes so that a person coming into a cloud facility, if I have 50 customers, I have 50 separate boxes that I have to manage. Yeah. It seems to me that encryption at layer 1 is the best way to address the issue, isn't it? As far as the transport layer.
Well, yeah, I mean, the security at layer, if you're isolating it down to layers, then layer 1 is a good one to start with because it's, you can't tap it from the internet. You don't have the layer 3 access and ubiquitous access to the internet into it. But even that is still got risk because, you still have to guard against the interfaces that are, ultimately, at some point, IP interfaces into the control of the network just from a usability standpoint, interface standpoint, and so you have to protect that. And then as you're going into, and then as you start working through the layers and start working the interactions between layers, all of those interfaces, all of those points of connection and communication between there start to, open up the areas for risk. And so it is definitely a multi-layered security model that you've got to think through.
And your first question makes it harder. Do you make this open? Yes, absolutely, you make it open. And when you make it open,
yeah, it's open to people that are interested in.
So we have to tackle it, but we have to tackle it in an open way.
One thing I will say though is that the things that we don't. There's a lot of things that we don't know. But what we do know is just the general trend that companies, people, humans want to do things more themselves. Okay, which is a change from that. That hasn't always been the case. People used to want to interact with another human and have somebody, and that felt like good service. Today, good service is somebody being able to do it themselves on demand and also do it near real time and have it happen as fast as possible. Right. Those two dynamics in terms of the evolving future of customer service is ultimately going to, we got to use that to say these are problems that we have to solve. We can't just sit around and say, well, I don't know if the economics aren't going to work. I don't know if in the end, these are big forces that are whether we individually in our companies cooperate with it or not, are going to progress forward and force evolution in this.
You got to provide a service that matches the workload requirement of the customer.
Yeah. Mm-hmm.
And I think that should be the goal. Now, how do we get there? And the first person to get there is going to be disruptive. Mm-hmm. We've run out of time, so I don't think we have too much. We don't have time for questions because we've run out of time. But I want to thank you for joining us today. I really appreciate it. It was a great discussion.
Okay, thanks.
Great.
Thank you.
Thank you, everybody.
Thank you.
Thank you.